morning, students. I welcome you all for another lecture on the course Computer Architecture and Organization. From the last few classes, we are discussing about different techniques what we are using for making of control unit. In that process, we discussed about hardwired control unit. In the next lesson, I discussed about microprogrammed control unit. And in this lecture, I am going to focusing on another topic which is related to control unit, that was micro instructions. Right, straight away we are entering into the concept. The micro instructions are used to perform micro operations. What is the use of this? The micro instructions are used to perform the micro operations. Then, a set of micro instructions are called microprogram. A set of micro instructions are called microprogram. In the execution of any machine instruction, the number of micro operations are performed internally. That means in order to execute any machine instruction like add R0, R1 or move some R0, in brackets of R2 or SUB some R3, R4, these we are calling as machine instructions. In order to perform these machine instructions, number of micro operations are performed internally. If I do a number of machine operations, that means in order to do a number of micro operations, definitely I am going to execute a microprogram or a micro routine which consists of a number of micro instructions. That means an instruction execution consists number of micro operations. To perform micro operations, we are using a micro instructions. Set of micro instructions we call microprogram or micro routine. So it means microprogram can be executed internally in the machine instruction execution. Right. A micro instruction is a set of binary bits. In it, some of them are set to 1 and some of them are set to 0. That means your machine instruction is, again it is 1s and 0s, and here your micro instruction also 1s and 0s. That means if you consider a micro instruction, some of the bits are set to 1 and some of the bits are set to 0. Here the bits who are set to 1, it represents some control signal. That corresponding control signal is activated, and the bit value in a micro instruction is set to 0, it corresponding control signal was active. So, here a micro instruction consists a group of binary bits. In that, some of them are set to 1 and some of them are set to 0. In order to get a clarity about these particular statements, I took an example. For example, here my instruction is add some R1, R2. In order to execute this instruction, first of all, what I have to do? I must fetch this instruction from the memory. Later I must decode this instruction, and later I execute this instruction. That means this instruction is a machine instruction. In this machine instruction execution, I was doing number of operations. Let I assume these I can call as some machine operations. So each machine operation I consider as one machine cycle. That means an instruction cycle, here I written as simply IC. An instruction cycle divided into number of machine cycles MCs. Like this, number of machine cycles. Again, if I come into this machine operation, which is a fetch operation, in this fetch again I was doing a number of the smaller operation or elementary operations. Those elementary operations I can call as micro operation. For example, in order to fetch this instruction from the memory, the first thing is my program counter PC has to generate the address of this instruction. Like you can assume this instruction is available in a location some 2000H. This 2000H address is generated by PC. The PC generated address was transferred to the memory with the help of a MER register. So PC value was transferred to MER. So this is one operation. Later MER placed that address onto the address bus. Later my CU generate a control signal, that was the memory read, and later your memory go and place this instruction on the data bus, and later that instruction was read by the CPU, which was copied onto MBR, and later that instruction was transferred to instruction register IR from MER. These are the number of elementary operations are going on in this fetching operation. That means this machine cycle can be divided into number of elementary operations. Those we can call as our micro operations. In order to perform this micro operation, what I want is I want micro instructions. In this, for example, my operation is PC to MER. It is one of my micro operation. In order to perform this operation, definitely I must generate a control signal. To go and give that signal to the PC, you have to go and place your information onto the internal bus. That means, let you can assume this is my program counter PC and this is my internal bus of a CPU, and here I have my register MER. The information was copied onto this PC through this. It can be controlled by PC in control signal. And once the data is copied onto this, later it is placed onto again internal bus through another buffer. So it is controlled by PC out signal. So here this PC in and PC out are the control signals which are needed for me to communicating with the PC. In a similar way, to communicating with this MER also, I need a control signal MER in as well as MER out. So these are the control signals I needed. So in order to perform this simple operation, first I must activate this PC out signal. Then PC value is based on this internal bus, and later that value is copied onto this MER by activation of MER in signal. Right? Later this MER value is transferred to memory by using memory bus. So in that case, it will go and place the data onto my internal bus, that is an address bus. So here I need a control signal, that is MER out. So in order to generate these control signals, I have a different bits are exist in my micro instruction. In that micro instruction, I am talking about all these control signals, but for doing of this particular micro operation, I must activate this PC out signal as well as I must activate this MER in signal. Later I must activate this MER out signal. So these corresponding bits in my micro instruction is set to 1 and the rest of the bits are set to 0. So here to do this each micro operation I need a micro instruction. So to perform all these micro operation I need a micro instructions. Like this. Similar case for this machine cycle and similarly for this machine cycle. Then all these group of machine instructions or micro instructions I can call as a micro program or micro program. That's what I'm mentioning here. So micro instructions are used to perform micro operation, that is this. And second thing, a set of micro instructions are called micro program. These are the set of instructions I can call as micro program or micro routine. In the execution of a machine instruction, number of micro operations are performed internally. This is my instruction. To perform that, so many internal operations I was performed. It means a micro program can be executed internally in the machine instruction execution. It is absolutely true. At the end, a micro instruction is a set of binary bits. In it, some of them are set to 1 and some of them are set to 0. In order to activate the control signals which are necessary to perform a micro operation, those corresponding bits are set to 1. Whatever the control signals that are not needed for that operation, their corresponding bits in the micro instruction is set to 0. That is the meaning of this. Next, there are two types of micro instructions for us. That means there are two varieties of micro instructions. Those are, one is vertical micro instructions and second one is horizontal micro instruction. There are two varieties of micro instructions for us. What is vertical micro instructions? Each micro instruction specifies single or a few micro operations to be performed. That means with the help of a single vertical micro instruction, either I can perform a single micro operation or a few micro operations. That means by using vertical micro instruction, I generate the control signals which are necessary to perform either single micro operation or more than one micro operation. That's why here I written as few micro operations. Alright. Second one is horizontal micro instructions. Each micro instruction specifies many different micro operations to be performed in parallel. That means by using a horizontal micro instruction, I am going to generate a more number of control signals. Those are helpful for me to do more number of micro operations. That is the meaning of this tool. Now I can go and discuss this vertical micro instruction as well as horizontal micro instruction in detail, right? So first I am going to talking about vertical micro instructions. So here the first point is width is narrow. The meaning of this particular statement is the size or the number of bits present in this vertical micro instruction is less. That means I have a few bits are present in a vertical micro instruction. That is the meaning of this. N control signals encoded into log to n bits. For example, I would like to generate 16 control signals by using this vertical micro instructions. In that I have just 4 bits are exist because log base to 16 is equal to 4. So with the help of 4 binary bits, I would like to go on to generate 16 different control signals. So instead of using 16 bits, each bit for one control signal, here I am going to use only just 4 bits. That means I am going to generate my 16 control signals only with the help of 4 binary bits. Due to this, the width of my micro instruction is less. So that is the meaning of first and 2. The second one is limited ability to express parallelism. Absolutely. Why? Because each bit combination refers to one control signal generation. If you took this example, here I have a 16 control signal. That was my aim for generation of it to do different micro operations. If I select the vertical micro instructions, in order to generate this as 16 different control signals, I just go and use only 4 bits. So that means with the help of these 4 bits, at any instant of time, I would like to generate only one control signal. That means I have gone to do only one operation. So one smaller operation or an elementary operation or it's maybe micro operation. So that's why here limited ability to express parallelism. That means I was not unable to generate more than one control signal at a time in case of vertical micro instructions. Next, the considerable encoding of control information requires external memory word decoder to identify the exact control line being manipulated. That means here definitely I was depends on a decoder circuit, because here I took a decoder circuit. The output of this decoder I have a control signals for these are 16, but for this decoder my input are just only 4 bit input. So here the job of this decoder is it has to identify the applied code belongs to which control signal out of 16 that I have to go and decode. That means here is the decoder circuit plays a considerable amount of information. You have to remember that with the help of this decoder itself only, I would like to identify for so and so code which control signal will be generated. So this is about my vertical micro instruction. See here friends, here there are different functional codes. So this is a group of bits which represents one function. Here a group of bits that represents another function. This is a group of bits that represents some other information. So ultimately, no doubt every instruction must have a next micro instruction address. So after execution of this, I would like to go and generate an address from which I am going to access my next micro instruction from my control memory or a control store. So in addition to that, each and every instruction has jump condition. Because once you refer to a microcontrolled unit for generation of control signal, the control signals are purely generated based on different information. In that case, I consider the conditional codes, I consider IR information, I consider previously executing instruction information, I consider some other control signals what I received from an external bus. Based on all these things, I would like to generate the control signals which are necessary for current going operation. So that here these are very important for me. By considering all these things, I would like to generate what my next micro instruction address and what the control signal that is necessary to do my operation. So this is a simple format of vertical micro instruction. Next, coming to horizontal micro instructions. it is a somewhat different from vertical. So the first point represents that wide memory word. That means here the instruction size is somewhat bigger one. That means the width of micro instruction is somewhat large. Because in this case it is very clear. In previous slide I clearly mentioned that each micro instruction which belongs to horizontal, in that case I would like to generate a control signals for more than one operation. That means I would like to generate a more control signals. So that's why here the size of your micro instruction is somewhat wide. And next one is a high degree of parallel operations possible, because here I have a different bits. Each and every bit is helpful for me for generation of one particular control signal, so that a single micro instruction can able to generate multiple control signals. Here I need not be want any encoder and decoder circuit, because here I am not using only encoding form, because I directly go and use the bits what I have in my horizontal micro instruction. Each and every one is used to represent one control signal. If I want to need a particular control signal, the corresponding bit in my micro instruction is set to 1, which is not required for me. That corresponding bit I make it as a 0. So that's why here more parallelism exists in case of this horizontal micro instructions. Next, little encoding of control information. That's what I am saying. The controlling information, I didn't want a much more of encoding as well as a decoding process in case of a horizontal micro instructions. Right. So this is the structure of my horizontal micro instruction. So up to this, these are the bits I was dedicating for internal CPU control signals. This I am going to give the control signals for internal of my CPU. That means I may generate the control signals for internal registers, or I may generate the control signals for an ALU to do different operations. And these are the set of the bits are helpful for me to go and give a signals to my external world. That means with the help of this set of bits, I can communicating with the external memory, or I am going to communicating with my IO devices. And as usual, I have a jump condition, and as usual, I have a next to my instruction address. So here, if you are observing this, with the help of these bits or with the help of these bits, I would like to generate a control signals for the internal part of my CPU or external to CPU. So here I didn't want much more encoding as well as a decoding process. But in case of vertical micro instructions, definitely I must go and use the encoding process as well as decoding process. So I hope you understand what this horizontal and vertical micro instructions are. So thank you for patient listening. In the next class, I am going to discuss about micro instruction sequencing. Thank you very much.